Hi, I'm David Yalin. I'll be presenting work from my period in the Hebrew University about the effect of treated wastewater on oxygen dynamics in avocado planted in clay soils and the implications on plant sodium homeostasis. So the motivation for our work is that today in the world, treated wastewater is widely used for irrigation. And the areas where treated wastewater is being used for irrigation are areas where avocado and citrus subtropical fruit are commonly grown as main crops. Areas such as Central America, areas such as the Mediterranean, South Africa, and Australia. And in Israel, what we are seeing is that these crops, subtropical fruit, are losing yield following irrigation with treated wastewater after consecutive years of irrigation with treated wastewater. And this yield loss has been reported so far mainly in clay soils, with around 60% clay. That's it. So I'm showing here an example from the work of Paudel et al., showing about ruby red grapefruit. And what you can see here is that after something like 4 years, the yield of the treated wastewater irrigated orchard declined significantly as compared to the freshwater irrigated orchard. And in avocado, we see a decline of up to 40% in yield of Hass avocado following this irrigation with treated wastewater. And the association with clay soils led us to believe that the damage is caused by lack of oxygen in the soil. I should also mention that in the citrus and avocado where the yield has dropped, we do not see any elevated levels of sodium chloride or boron, or we don't see toxic levels of sodium chloride and boron in the leaves, leading us to believe that the damage is related to soil oxygen rather to toxicity by these elements. Now, oxygen has been long recognized as a cause of damage to plants, lack of oxygen. Even Virgil the poet, already 2,000 years ago, mentioned that when you plant a vineyard, you should make sure that there are porous stones in the soil so that oxygen can penetrate and so the sown plants will breathe. Of course, since Virgil the poet, we have advanced a bit. And nowadays, we know that oxygen retards plant development, and in the literature, 10% by volume oxygen is known as a limiting value for plant production. Except for that, we also know that lack of oxygen or hypoxia leads to decreased salt tolerance. Here from the work of Barrett Leonard from his review, what you can see is that the damage from sodium chloride was elevated in the presence of hypoxia, when also the plants were suffering from hypoxia. And the damage from hypoxia was greater due to the existence of salinity. So these are two options that we looked at, the damage from oxygen and from salinity being exacerbated by hypoxia. And we asked two questions. One was, does treated wastewater affect soil oxygen dynamics? And the second question was, if it does affect the soil oxygen, how does that imply to the plants? And is that something that can cause the yield loss? So our methods, we performed a 2-year field study in Acre in the Western Galilee in Israel. This is one of the greatest producing areas of avocado in Israel. So our research site represents a wide area of Israel that produces avocado with treated wastewater on clay soils. We studied Hass avocado planted on a vegetative clone rootstock number 66, which is from West Indian origin. You can see here the long-term effects of irrigation with treated wastewater. Both orchards were on 60% clay. And you can see that the long-term irrigation with treated wastewater elevated the salinity in the soil, nearly doubled it, and nearly raised by 7 the sodicity of the soil, the sodium absorption ratio of the soil. And in these sites, I'm going to present measurements that we performed at 35 centimeters. Actually, the people who performed the actual measurements were Shmuel Asulin and Kfir Narkis. I'll present their data. And I'll be presenting root growth data, which our colleague Amra Meshel performed, and mineral content that we measured in excised roots as well. So we'll start with soil water dynamics. What you can see here is that this is a period of 2 weeks from the irrigation period in the summer in Israel. In the Western Galilee, it's common to irrigate 3 times a week, each irrigation event marked by a vertical line like this. And as you can see, after each irrigation, the soil was saturated, both treatments, but in the treated wastewater irrigated plots, the soil was maintained at much wetter conditions as compared to the freshwater irrigated plots. Now, we'll look now at why this is so. So we looked at the drying rate in the soil. This is just a derivative of this. The water loss, percent water loss from 35 centimeters depth per 3 hours period. And within this water loss, we analyzed 2 periods. One period is the dark hours, and in the dark hours between 6 in the evening and 6 in the morning the next day, the water loss we attributed to drainage, free drainage from the soil. And the light hours between 6 in the morning and 6 in the evening, which we attributed to transpiration mainly. What you can see here, analyzing for these 2 weeks that I showed before, is that in each irrigation, the nighttime water losses were significantly greater in the freshwater irrigated plots, meaning that drainage was significantly greater in these plots as compared in that soil, in the freshwater irrigated soil, as compared to the treated wastewater irrigated soil. On average, 2.5 times greater drainage in the freshwater irrigated soil as compared to the treated wastewater irrigated soil. A similar trend we see in the daytime drying. Treated wastewater irrigated plots dried significantly slower as compared to freshwater irrigated plots, on average 3 times slower, so 3 times less transpiration from 35 centimeters depth. Which also means things about the plant, obviously. Now, looking at how this soil water dynamics affected soil oxygen, what you can see is that because the soil was maintained in wetter conditions for a longer period of time, the soil oxygen levels, which declined after each irrigation, was maintained in low levels for a longer period of time and managed to reach also lower levels as compared to the freshwater irrigated plots. So there were longer periods with hypoxia in the treated wastewater irrigated plots because the soil was maintained wet, so it didn't allow oxygen penetration from the atmosphere above the soil. Now to sodium homeostasis in the plant. Here I'm showing results of a root analysis, and what you can see is that sodium levels in the treated wastewater irrigated plants were significantly higher in all 4 sampling dates, despite a decline during the spring in the sodium levels in the roots. During the season, we see consistently higher sodium levels in the roots, which we expect would damage these roots. On average, there are 3 times more. We found 3 times more sodium in the roots of the treated wastewater irrigated plants as compared to the freshwater irrigated plants. These elevated sodium levels in the roots also affected sodium levels in the xylem, but did not reach the leaves, which you can see, which in the leaves we actually found lower sodium levels in the treated wastewater irrigated plants. And this suggests, in our opinion, that there is a sodium retention mechanisms in the roots and xylem of the tree that prevent sodium from reaching the leaves and causing sodium toxicity there. And this has been reported in the literature before years ago. An effect on the plant that we did trace was, first of all, that we found a correlation between the percent of time below 10% oxygen, which I previously mentioned as a critical level for plant development in the literature. So the longer the plants were with 10% oxygen or lower, the less root growth rate we observed in these plants. This is one observation that we see, a correlation between the two of these. And the second correlation that we see is between the sodium levels that we found from excised roots and the rate of growth into the ingrowth cores that we took out. So here I'll conclude and say that our findings, what we suggest based on them is that treated wastewater affects soil water dynamics. So it retards the soil water drainage, what we saw in the nighttime, much less water loss during the nighttime, leading to an effect on oxygen dynamics, retarding oxygen penetration into the soil in the treated wastewater irrigated soil. This affects the root growth. We believe that directly the lack of oxygen retards root growth, but also indirectly by exposing the plant to sodium damage. And this goes back as a cycle because the damage to the roots means that the plant takes up much less water, leading to further hindering of the oxygen levels. And this, of course, if there's damage to the roots in the long term, of course, affects the yield. To show a bit of prospects, based on our findings, we suggested 3 methods to mitigate the damage of treated wastewater. The first is the use of tuff ditches. The second, where the soil would be kept aerated. The second is low frequency irrigation, where the soil would be allowed more time to drain between irrigations. And irrigation with a mix of fresh water and treated wastewater. And you can see here, in a study by Bani Namera, that the tuff ditches were effective in increasing sap flow as compared to treated wastewater irrigation. And this shows that there is some future to these suggestions. I'll refer you to our 2 publications, to my publication about soil oxygen dynamics and Bani Namera's publication about the mitigation methods, and of course our publication in Acta Horticultura. And with that, I'll thank you for listening, and to all the associates and the ISHS for the funding. Thank you very much.